A content delivery network, or CDN, is a globally distributed fleet of servers that delivers web content from locations close to the user. Instead of every request crossing the planet to hit one origin server, copies of your assets live on edge nodes spread across continents, ready to serve traffic in milliseconds. Edge servers are the key. They sit in data centers near major cities, inside internet exchange points, close to where real users live. A visitor in New York hitting a nearby edge in New Jersey gets a response in single-digit milliseconds. The same request routed all the way to an origin in Frankfurt has to cross the Atlantic, adding 80 to 150 milliseconds each way. Geography is latency, and edge servers fix it. When a request arrives at an edge server, one of two things happens. On a cache hit, the asset is already stored locally, and the edge returns it instantly, blazing fast, no origin round trip needed. On a cache miss, the edge has nothing to serve, so it forwards the request back to the origin, waits for the response, delivers it to the user, and stores a copy for next time. Hits are the goal, misses are the cold start. CDNs expose what they did through HTTP response headers. Xcache tells you hit or miss. H reports how many seconds the asset has been sitting in cache. CF cache status, used by Cloudflare, expands the vocabulary with hit, miss, expired, and dynamic. And X served by names the exact edge node that handled the request, like cache, LGA 21947, LGA, which is a fingerprint telling you which machine in which city actually answered. How long an edge holds onto an asset is controlled by cache control. The directive public maxage equals n sets the time to live in seconds. Maxage equals 86400 means the edge treats the response as fresh for 24 hours before revalidating with the origin. Bump it to 315360000, and you have a year-long cache. Tune it carefully, because it directly trades freshness for speed. In this demonstration, we'll inspect HTTP response headers from several CDN-fronted websites using curl. By examining headers like xservedby, xcache, and cache control, we can see whether a request was served from a nearby edge node or fetched all the way back to the origin, and how long the response is allowed to be cached. We start by clearing the terminal so each command and its output is isolated and easy to read. The clear command simply resets the visible buffer, giving us a clean working surface for the inspection that follows. Our first real inspection targets example.com. The SI flags tell curl to run silently and fetch only the response headers, not the body. Notice the cache control header announcing a TTL of 86,400 seconds. That's a full day of caching, along with an age of 0, confirming this is a fresh miss served directly from the origin. Next we hit CDN.js, a CDN-hosted library repository. The xservedby header reveals the specific edge node handling our request, and the xhit header gives us a binary cache indicator. A value of 1 means a hit. The asset was already cached at the edge and delivered without round-tripping to the origin. This command demonstrates a quieter curl invocation. The o/dev/null discards the response body, and the W format string prints just the HTTP status code. It's useful when you want a quick health check without cluttering the screen with full headers. Now we probe Cloudflare.com itself. The CFRay header is Cloudflare's request fingerprint, and the embedded airport code reveals which data center answered. The cache control TTL of only 600 seconds, 10 minutes, is unusually short, reflecting the marketing site's need for near real-time content updates. Our final inspection targets the unpkg CDN. The H header of 180 tells us this asset has been sitting at the edge for 3 minutes already, and the long cache control TTL of 31,536,000 seconds, a full year, matches the immutable nature of version package files. We close the session with a simple echo confirming the inspection run is finished. Across these requests we've observed cache hits and misses, traced edge nodes by their xservedby and CFRay identifiers, and compared cache control TTLs ranging from 10 minutes to a full year.